Welcome back. In this session, we are going to discuss about slicing, how to slice the data using in MDX queries. So if you take a simple MDX query, select star from AdventureWorks, the cube name. AdventureWorks is the cube name here. It will give you the default measure name. The default measure for us is sales amount. Here, if I want to get different measure value apart from the default, then you can use it in the where class. For example, select from cube name where measures dot tax amount. You see it is going to return tax amount. Now, if I try to execute the second query what you are seeing on the screen, that is select measures dot sales amount on column axis from cube name where measures dot sales amount, there will be a conflict. Why? Because two different axes are having the same hierarchy members. What is the same hierarchy that we are using here? Measures is the same hierarchy. You can see measures is used in column axis as well as in the where class, which is not allowed in MDX. So if you execute this, it is going to throw the same error. The measures hierarchy already appears in the axis 0 type axis. So axis 0 in the sense columns here. That's what where I have defined the sales amount measure. Now let me take this. Let's see how to use where condition to filter the sales amount based on an year. So to filter the one, there is nothing like where equal to operator here. Generally in SQL Server you will have like this, where year is equal to 2001, which returns 2000 year sales. But here the case is different. You have to use members. That's why we had a big discussion on members in last session. So we have to use only members to filter, to slice the data. For example, if you see here, I've dragged the member 2001, and this query is going to filter the sales amount based on the year 2001. What I'm asking the server here is provide the sales amount for the year 2001, and if I execute the same, it will return sales for the year 2001. And one more query to check the same for the year 2002. What if I want to show this 2001 in the rows? I know I'm filtering the query. I'm filtering the sales amount based on the year 2001. And if I wish to show the same in the row axis, then how I can implement that? So I have to add comma. If I add calendar year, it will get you all the calendar years and then filter by 2001. If you think so, then it is wrong. Why? Because sorry, I have to add on one row axis. So why? Because again the same problem. The due date dot calendar year hierarchy appears more than once in two different axes. If you see on row axis, you have the same hierarchy, and in the where condition, you have the same hierarchy. You cannot have such kind of we cannot execute such kind of queries where the same hierarchy is used in two different axes. So how to achieve that? I want to see 2001 in the result set, and I want to filter the data. I want to get only 2001 cells. Then you don't need where condition at all. So instead of going for where condition, use the measure in the row axis. Sorry, use the member in the row axis. So this means I'm asking the server to give me the sales amount for the year 2001, and I want the 2001 to be displayed on the row axis. And if I execute this, you can see 2001 on the rows and sales amount, it is filtered. So slicing is where condition is not the only one where we can slice the data that is retrieving from the cube. You can slice even in axis 0, that is columns axis, or in rows axis. It depends on your requirement. If you want to show as well as slice, then use it in the rows or columns. If you just want to slice, then use it in the where condition. Now this is fine. Let's say I want to show the same data, all the years information, not 1 year information. I want to show all the years information. So what I have to do? I have to drag calendar year hierarchy. I drag at hierarchy level, so better to drag at attribute level. So this one will return. This is a simple index query which retrieves all the 4 years information of sales amount. So if you want to filter this, if you want to get only a particular month's information, how can you do that? You can have a where condition where you want to filter based on months, right? So go to the months and drag March. That means it will get only March sales of every year. You can see the sales are pretty less and you don't have data for the year 2001. Why? Because we don't have sales for year for the month of March in the year 2001. This is how you can filter by any member, by using any member, and you can display different attribute hierarchy in the rows and columns. How you can filter by using more than one? For example, here I am filtering based on March, based on for the month of March. Now, if I want to filter for the month of March and November, then how can I do that? So the way is you have to add comma and drag and drop November into this. So if I execute this, it will throw an error saying that after where class you have two members, okay, and that syntax is wrong. It should be either in flower brackets or parentheses. What these two will form? The month March and November will form. What it is going to form? Is it going to form a set or a tuple? So it's going to form a set. Why? Because both are having same hierarchy. You can see due date dot months is the hierarchy for the March, and due dates dot month is the hierarchy for the November. So this forms a set, and hence you have to keep it in flower brackets. Now I'm going to filter the sales amount for all the years for the months given, that is March and November. If you see, it is retrieving the data. Now we are getting 2001 sales. Why? Because 2001 has sales for the month November. How can you achieve that? How can you filter based on month by using it in where class? And if you want to show year also, month in rows, then how can you do that? The one way is directly giving this in the row axis. Instead of that, you can go for one more way. We defined a hierarchy for year, quarter, and month, right? So we will have that month in calendar hierarchy too. If you see here, you have English month name here. You can use this, and these two will form a tuple as the hierarchies are different. So, and you can see none of the hierarchy is repeated. Every hierarchy is used only once, and you can see 2001 November, 2002 March, 2002 November, 2003 March, 2003 November, and 2004 March. So this is how this is one advantage of having hierarchy. You can use it in where class. You can filter based on some attribute hierarchy, and the same hierarchy, if you are using in the user defined hierarchy, then you can make use of the same to display purpose. You can see the English month name by dragging from calendar hierarchy. I'm using it to display in the result set, and the months whatever I've defined in the attributes list, I'm using it to filter the data. So this is how you can filter based on more than one member. What if you want to filter based on two different attribute hierarchies? Members from two different hierarchies. An example is, let me take this. This is year's information for the month of March, and I also want to filter a particular product or particular color sales. So if I want to do that, what I have to do? I have to drag and drop the color, what color I'm looking for, based on what color I want to filter. For example, if you see the color, and let's say I want to filter based on the color black, and I have to simply drag and drop it. What this one will form? This one will form a tuple as the hierarchies are different. You can see the March member March hierarchy is due date dot months, and member black hierarchy is products dot black. Now this guy will return sales for all the years where month is equal to March and color is equal to black. It will filter all that and it will retrieve the data. So this is how you can use sets, you can use tuples in the slicer class, that is where class, to slice your result set. Is it possible to use more than one set, and is it possible to use set as well as tuple in the where class? Yes, it is. Let's see how to. Let's say your requirement is you want to get the sales for the month of March as well as what is the other month we have taken? It is November, right? So November. Then what this guy will be? These two will form a set. The month March and month November will form a set. So make it as a set. And the second guy is color black. And let's say I want to add one more color, that is NA. Let's add NA. So these two guys will form a set again. So in the where class, I have overall tuple. This is a tuple which is collection of two sets. This is set 1 and this is set 2. And let's try to filter the same. You see, it is retrieving the data. So this is how you can use measure to filter. You can use sets to filter, you can use tuples to filter, you can use single members to filter, either from hierarchy or from attribute hierarchy or from user defined hierarchy. So by having knowledge on these things, whatever we discussed till now, you can write as complex where condition as possible, as required. For example, you can add some 10 to 15 members in the where class, but what you have to do is you have to go for proper analysis before writing the where class. The only exception is if you add something in the where class. For example, if you use this one, if you are using March and you are using November in the where class, but you cannot show that in the rows or columns. Why? Because this hierarchy is already used in the where class. That's the only problem. If you want to use it in the where class, then simple. Select everything, cut this, and after this add a comma, done. And what these three guys will form? Now not only these two, even the first one, all these three will form a tuple. So overall this is a tuple now up to here, and this tuple has one attribute hierarchy, this one, and this is one set up to here, and this is another set. Okay, now if you see, this guy will filter as well as it will display the same in the row axis. So this is how, based on your requirements, whether you want to display, whether you want it to display in your reports, then use it in the rows or columns, else use it in the where class. There is one more way, as we discussed about except, right? For example, you have so many products. You don't want all the products. For example, you don't want couple of products and you want the remaining products. Let's see how to filter that information. Sorry. Let me take the query here, and I can reuse the same. So this is a select statement where we are getting sales amount, and due date dot calendar year is on the rows, and let's say I'm getting March sales and product is black. Now I want to form a tuple with a different. For example, I don't want March. I want everything except March. So in that case, how can I go for? What I have to do is, first I have to write except for these particular months. So I want all the months except this guy. This is one, and the next one is that cross joins with the black. That means I want January, February, April, May, June, July, August, September, October, November, December sales where the color is black. If you see, it will give you the result. The result is pretty high. The values are pretty high. Why? Because it is all 11 months information except the March for the color, where the color is black. So can I have one more except for this? You can. You can have one more except for colors if you wish to. For example, I'm going for color. Get me all the colors, sales, okay, comma, except black. So this is one except, that means get me everything except black color, and this is one except, get me all the months information except the black color. So if you see, it will be even higher the sales. Why? Because earlier we were getting only black color sales, now we are getting all the color sales except the black. So this is how you can use except. And again, if you see the except, it's not only one color filtration. You can filter more than one color. How? This is one. What is the next one? Let's say if next one is NA, not applicable color. You don't want this guy to. So what these two will form now? These two will form a set. I cannot leave it as is. If I leave it as is, then this one will become one parameter. This one will become one parameter. Generally, parameters will be separated with a comma, and this guy will become one parameter. So it says you are passing three parameters to the function except, but accepts only two parameters. Yeah, the three argument to the except function must be a flag. So the third one, what we have to do? These will form a set. Get me all the colors except the set of colors. So what are the set of colors? The black and not applicable color. So if you first analyze the requirement, then you can build the MDX query. It starts with a simple MDX and it will continue to be it will grow like anything. Let's say my requirement are growing now. First, this was my requirement. Now, if I want to show months or products in this one, then I will drag and drop products. If products needs to be displayed in the result set or in my report, then what I have to do? Simply I have to drag the product name, English product name into the rows. So these two guys will form a tuple. So I'll keep it in parentheses, and you can see this become even bigger MDX query. This is how the MDX queries come. Once you get this result, after seeing this result, what you have to do? You're getting so many nulls, so you have to filter nulls. You don't want nulls, so filter it out. So this is how you have to build the MDX queries. It's not like all of a sudden writing the big complex MDX query by seeing the requirements. First, start from the minimum thing. What is the where condition? What is the columns you're looking for? What are the measures? What are the attributes you want to? What is the attribute hierarchy members that you are expecting in your result set? So analyze that, then split the requirements, start from the smallest one and keep on adding to the query, existing query to build the complex one. So this is how you can use except, and you can use where class, or you can directly use members to filter the data. I've shown a couple of examples here and you can apply. See, there is nothing else. There is no other way that you can go for more than this. We have discussed almost all the possible slicer conditions. And what will happen if I add not here? Where not blah blah blah. I've given some not condition. It won't accept. Let's try it somewhere else. Okay, fine. So this is about where class and slicing of the cube, and now we're gonna discuss more about non-empty function. I don't say that you are expert in non-empty function. You are expert only in non-empty keyboard, but we are gonna discuss about non-empty function here. So there is one function and this is the keyword. This keyword, what it will do? It will filter. If the complete row is null, then it will remove the particular row, or if a particular column is null, then it will remove the particular column from the result set based on where you have defined this. If you have defined it in the rows, then it will apply on the rows. If you define it on the columns, then it will apply on the columns. But this non-empty is slightly different. Now let's see how to make use of the non-empty function. Before explaining this, let me find out the correct query, what query will suit to the requirement. For example, let me take a simple query like this. Select, I'm getting sales amount, comma, tax amount. I'm getting two different two measures in. I'm using two measures in my columns. So these two will form a set. So I'm making it as a set on columns, comma. I'm taking color attribute as well as English product name in my rows. These two also will form a set, tuple on rows from the cube name. So if I execute this query, you can see the output. Okay. Now let's see how to filter the complete null records. For example, this guy is having null, and the next record, this is complete null. This is also complete null, and this is also complete null. You are very well aware of that. You can do that by using non-empty before the row items. So this one will return only non-empty records. You can check there is no empty records here. Now I'm going to change this query a bit. I'm going to add one more measure, that is dim product, some standard cost. So what this guy will do is, I have three measures and two attributes, and you can see you have some values here, and you have null here, and here you have some value for these three, but the sales amount and the tax amount are nulls. Now let me try to filter the null records. I don't want to show this null record, so what I can do, I can use non-empty generally. If I use this non-empty, then this one will say stupid. This one will, I will filter the rows only when the complete row is null. But if you see here, there is no sales, you know that, and hence you didn't pay the tax. But the standard cost of this particular product is something, some value. But your requirement is, if the sales amount is null, then don't show it. If there is no sales, I don't want to see the product. Then how can you achieve that? You can achieve such kind of requirements only by using non-empty function. Main difference between the non-empty function and the non-empty keyword is, non-empty keyword will check for the complete row. If the complete row is null, then it will filter. But non-empty function is not like that. Non-empty function, it depends on whatever you provide. If you provide a particular measure, then it will filter based on that particular measure. Let's see, if the particular measure value is empty or null, then it will filter. Let me demonstrate the same. Let me show you an example. I have three measures here. You can see I have all the three. Now the non-empty will be given like this. Okay, the non-empty of, I have given these two attributes. I have not passed any measure. So it is checking that if a particular value is empty, then if any of this value is empty, then it is not returning the data. Oops, sorry, I've done a mistake. Here, these brackets is for the tuple, not for the non-empty. Non-empty is a function, so you have to specify like this. Let me highlight and show. This is a tuple, okay, and this is a function. Function also have parentheses. Okay. Now if I execute this, you can see this acts as, this will check whether any value is null from any one of these three measures. If it is null, then it won't retrieve the data. Okay. Or if you want to specify it explicitly, like this is the result set I'm looking for in the rows, and I want to filter this result set based on sales amount. Let's say this guy. I want to filter this based on sales amount. I don't bother about tax amount and others also. I want to filter just based on sales amount. Then in that case, you have to provide that as part of the function. So you can see it is filtering the products and the products based on or the row items based on the sales amount. The non-empty function syntax is like this. You can give any set or tuple here as the first parameter, comma, the measure based on which you want to filter. If you don't provide any measure, then it will take all these measures. It will check for any one thing. If any one is null, then it will remove that particular record. It won't keep that record. Or instead of, if you want to filter based on any particular measure, if any particular measure is null, then hide that or exclude that record. Then you have to specify the record here. You can specify or not. If you don't specify, it will take the measures that are present in the rows, in the columns, and it will apply the non-empty condition. In short, the most simplest way to explain the same, non-empty keyword will take the columns, measures that are defined in the columns, and it will apply, what is that? Union and intersection, right? Or it will check all should be null. Non-empty function, first it will check whether any measure is passed or not to the function, like this I have done here. If any measure is given here, then it will check if that particular measure is empty. If empty, then remove the particular measure given. If the measure is not given here like this, then it will take all the measures that are present in the columns, and it will check if any one of the measure is empty, null, then it will eliminate the record. So this is how non-empty function works and non-empty keyword works. And this is very important. See, filtering based on non-empty or removing the nulls based on non-empty is not always suggestible. Let's say you have let's say this is your result set. You have 50 crore records like this. In that, all nulls are just only 50. All nulls. Let's say the complete row is null is just 50 records. Like this, complete row 15, only 50 records are nulls among the 50 crores, but 49 crore records are nulls for the sales amount. In that case, I don't need to get that 49 crore records, right? So which one I have to use? I have to use non-empty function in that case, or else I cannot get the required output. If you want to filter based on a particular measure, if a particular measure is empty, then eliminate the complete row, then go for function, non-empty function. If the complete row is null, then if you want to eliminate the record, then go for non-empty keyword. Now here I have given only one measure. What will happen if I give one more measure in the non-empty function? If I give one more measure, what this guy will form? These two guys will become a set, and if you provide the set, then it will check if these two, any one of this one is null, then it will finish it. It will eliminate the record. If you see in mathematics or in programming language, non-empty keyword will check for AND condition. If this is null and this is null and this is null, then remove it. But non-empty function will check for OR condition. Either this is null or this is null. Remove the record. So this is the simplest way I can explain the difference between a non-empty function and the non-empty keyword. Now let's jump into the next function, that is top count. How to get the top count records, top 10 records or top 50 records. We have seen some functions in last session like head and tail. Those functions like head is used to get the top n records. Tail is used to get the bottom n records. Now let's see how to get the top n records ordered by some measure, any measure of your wish. For example, if you want to get top performing players, then you have to use the measure runs. Which guy is hitting more runs. In the same way, if you want to get top 10 bowlers, then what you will do, you'll check either for average or for wickets. So in the same way, for any products, you will go for sales. Let me write a simple select statement. Select sales amount on 0, comma, I'm taking English product name on 1 from cube name. So this will return all the products and its sales amount. If I want to get top 10 records, just top 10 records, then I can go for head. Right? If I go for head, then this one will retrieve. I have to specify, right, some number. If you don't specify, it will take only one record. I've given 10. So what it will retrieve is, it will retrieve the top 10 products. The SQL query similar to this one is select top 10 star from dim product or some table name. So this is the SQL equivalent query for the above given head function query. Now, if I want to get something like this, select top 10 star from dim product, order by, let's say order by some sales amount, some column, order by sales amount, descending. So this guy will filter, this guy will order everything in descending order, and this guy will get top 5 records, top 10 records, right? So if you want to achieve similar kind of thing, then you have to go for a function called top count. Let's see how to implement this top count function. I'm taking the same query. Instead of head, I'm taking top count. So top count of 10. What it will return? It will return the same sheet. It is not ordered. It is not getting the top sales product. Why? What could be the reason? The reason is you are asking to get top 10 English product names. You are not specifying any measure. It will take the third parameter. If you don't specify the third parameter, then it will be it will be equal to head function. If you don't specify, if you don't provide the third parameter. The third parameter for the top count function is the measure. Any measure based on which you want to get the top sales, you have to provide that. If I've given sales amount, and if you see now, it is getting the top 10 sales amount, top 10 products having the good sales, top sales. So the difference between head and top count is the measure that you are giving. Based on this measure, it will filter, it will order, and then get the top 10 records. Now, I want to see sales amount wise, but I don't want to filter based on sales amount. I want to get top 10 standard cost items, standard cost English product names, and then, but display sales amount, display different measure. Use some measure for ordering purpose and display some other measure in the result set. So these guys, these top products, these products are having top standard cost, but sales wise, if you see, it is different. It is in descending order. If you have any query, you can test it by giving the sales, standard cost in your columns. Let me give it here, and if you execute this, you can see this guy is having highest, next, and so on. This guy is the 10th in the list. So this is how you can use top count function to get the top sales. And you are very well aware of the tail function, which we discussed in last session, and hence I'm not going to spend much time on bottom count. What this guy will do, don't you know? Bottom count will get least 10. So this is the least product. This is the products with the least sales. Now we get a chance to discuss about non-empty function again. If I apply non-empty function, there is some requirement. For example, say you have to get the last 10 products 10 products with the least sales, and the sale should not be null. Now if you see, all the things are null, right? So if you apply non-empty keyword here, what will happen? It will get this and it will filter and it will show nothing. Why? Because I got 10 products and all the 10 products are null, so it is eliminating. So non-empty keyword will not work fine for this situation. The one which suits better is non-empty function. Why? Because I can first filter the non-empty function here. Non-empty function for this particular measure and then get the bottom sales. First, filter it out. First, filter the 10 products. Remove all the nulls and get the products first. From that product list, show me the bottom 10 sales. So this is one example where you can use non-empty keyword and non-empty function. So if you see here, we have seen top count function, right? Top count function, generally it gets the top 10 or so top something. There is one more function similar to top count. I'm not gonna spend much time on that. Why? Because it is very close, very similar, except a little change. Let me explain it. Top percent. So if you execute this, what it is gonna return? It will return some records, some XYZ records. So these records is nothing but this function is top percent, and what it means is this is 10%. 10% of the total sales. Get me top products whose sales will contribute 10% to the overall sales. So if you don't believe it, let me copy this. I'll take an Excel. And let me copy the value here. It won't give you exact 10%. Why? Because it is not possible to get 10% exactly always. So what it will give you is, it will give you very close value. What I'm doing is, I've taken all the three. I'm taking the sum of these three values, and this is the sum of these three. Now I'm taking one more query. Sorry, I'm writing one more query. Here I'm not using any sales or some top count. Sorry, I'm not using any filtration part or top count. I'm getting all the product sales. The only thing I'm gonna do is, I'm gonna filter the nulls. Nulls are not gonna contribute to the sales, right? Total sales. So I'm removing it. I've taken these sales, and if you see, I'm copying it here. I'm taking the value is equal to sum of from here to the end. I don't know how many I have. Looks like a pretty big one. So this is the total sales, and this is the top 3 records that I got when I have given 10%. This is equal to this divided by this. Sorry. And you can see it is 13%, very close to the percentage that I have given. I have given 10% and it retrieved top 3 records which contributes very close figure. Why? Because it is not possible to get exact value, exact 10%. So it will get the close. Sometimes people will ask for reports like this. Get me top products which are contributing 25% of my total sales. In that case, what you have to do? Simply use this function and provide 25 there, and this will retrieve the products which are contributing 25% to the sales. And if I remove top and if I give bottom, it's spelling wrong, it will give you bottom products, least products, which will contribute 25% of the sales. Here it might be nulls. You'll get some values which are having. Let me remove this here. I don't want nulls, right? I'll use non-empty. And you can see, sorry, this is the products, bottom products, which will contribute 25%. Let's see that is equal to sum of from here to here and this is the value I got. Now what I have to do is equal to this value divided by total sales. Should be, yeah, it is very close, 25.5%. So this is how you can use top percent and bottom percent functions to get the sales on percentage basis. Okay. Now let me take these two functions. There is one more, that is top sum and bottom sum. So what top sum will do? Top sum will get the value, it should be pretty big one. How many products, top products will contribute this much sales? If anyone says that the company has 50 billion turnover, then get me the products which contributed 20 billion in that. Top products which contributed 20 billion in that. In the same way, I can give it for bottom two. Bottom products which contributed 25 billion or whatever the value you are giving. If I add this, it will be very close to that. Let me copy this value. And if you see this, the sum is 14092. I think this is the total sales we have. 14092. I have given pretty big number. I have to remove a couple of things. Let me execute now. I have given pretty big one. So it is saying these four will form very close value. Let's see that. 25810. Here what I have given is 25 something blah blah blah. So this is how you can use top sum and bottom sum functions to get the number of products that are the products which are contributing, which are having the sales very close to the number that you have given. Okay, this is how you can use top sum and bottom sum. In this, getting the top and bottom, I mean, in the function set we have total 6, that is top count, bottom count, top sum, bottom sum, top percent and bottom percent. If you observe one thing, top count is nothing but order function plus head function. If you order the items in descending and get the head of top 5 or top 10, it is equal to the top count. In the same way, bottom function is equal to order function in ascending and order function in ascending and head function again, or order function in descending and tail function. So that is how you can make use of two functions, I mean head and tail with order to get the top count and the bottom count. So you can go for either way, but the performance wise it's better to go with top count and bottom count to achieve the requirement like this. We have done with good enough number of functions in today's session, and now we are going to jump into calculations. What is these calculations? You are very well known about the calculations that we discussed in SSAS. In the same way, you can create calculations in MDX2. There is nothing different, the same calculations. So to demonstrate the same, let me take an example from SSAS itself. We created a couple of calculations in our SSAS project, right? Let me take the same. I think it is here. The calculated measure, whatever I've created is test. So let me use the same. Select. Let me end it. Select. I'll take sales amount and I'll take the calculated measure, whatever I've created. It is a set on 0. I want to show month wise or product. Let me take product. Let me expand it here. I need some space. On 1 from cube name. What will happen if I execute this? It will get the calculated expression whatever I have written, and it will calculate and it will show the calculation value. Now I'm going to this cube, the calculation whatever I've written, and here I've written it. The calculated measure name is test. Select that. You can see there is there is a button called script view, right? To click on this, it will give you the script part. You can see the name of the calculation is test, and as this is the function, whatever we have written, that minus this, sales amount minus tax amount, and what format you want to show, whether it's a standard format or decimal values or percentage or dollars, whatever you want, and back color, how you want to set the back color, some coloring, whatever, we have given some functionality, right, some coloring and so on. So this is the expression, whatever I've used. Now let me use the same expression to create the calculated measure in MDX. How to create a calculated measure in MDX? Let's see that. To create a calculated measure in MDX, you have to use the keyword with member. Here you have to give the name, measures dot, let's say testing. I'm giving some dummy name called testing as, this is the syntax, this is the basic syntax up to here, with member name as, what is the functionality you want to write? Let me write the same functionality. This measure sales amount minus tax amount as so and so. That's it. The calculation is created with member name as the expression, whatever expression you want to give. Once it is done, then I can use the same in my select statement. This is my select statement, right? Let me copy the same. This is the this is a measure, the first one, and this is the calculated measure I created in the cube, and the third one is the calculated measure I created in, or I defined in MDX, that is this. So if I select all, if I set all the three, now if I execute this, it will throw error saying that the testing is not available. The testing is not part of cube, the testing is part of MDX, whatever I've written. So I have to include that and execute it. If you see, it is executing the same, it is returning the same result, but it is not formatted. Right? So this is how you can write MDX, calculations in MDX. Simple. And if you want to add one more calculation, you don't need to repeat the with again. With will be used only once. With needs to be used only once in a particular query, for a query. For one query, only one with is enough. After that, you have to start with member. What is the next name you want to give? This time I want to give best. I'm not having hierarchy measures and all. By default, it will be taken hierarchy as measures. I'm giving the name as best as Rupesh is a trainer. So this is some hard coding text. Rupesh is a trainer is a hard coding text. Now let me add that one newly created one also here, that is best. Now I have two calculated measures that I created in MDX, that I defined in MDX, one from cube and one is normal measure. If I execute this, it will give me Rupesh is a trainer. This is a hard coding value, hard coded value. So like this, you can create n number of calculated measures in MDX, but only one time you have to go with the keyword with. After that, you just need to start with the member keyword for creating the calculated measure. Now, before going into the complex calculated measures, okay, let's see the scope of the calculated measure. There are three scopes for the calculated measure. One is create, next one is with, and the third one is cube one. Cube one is nothing but the one which you have defined in the cube. Here you have defined it, right? This is the cube level scope. Cube level scope means if you create the calculated measure here, it will be available to everyone who is having access to this cube. The scope of the calculated measure that you created in the cube is everyone who has access to the cube. That is the scope of the cube one. So ignore about that. The with keyword, the calculated measure that you are going to create or define with using the keyword with, like in this case, is query scope. That means query scope means the complete query needs to be executed, then only it will work. That is called query scope. If you don't execute this one, and if you execute only select statement, it will throw error saying that where is that testing and the best measures. These are not found in the query. These are not found in the cube. So if you use the keyword with, it is query scope. What is the create keyword? Let me copy the same. I'm using create instead of with. Create member. Whenever you are using create, you have to go for current cube dot. Then only it will be created. And for the best, you have to specify, right, where you want to create it. You are going to create this calculated measure where you want to create it. You are going to create it for this particular cube. Oh, sorry, I have to specify cube name. What is the cube name? The cube name is AdventureWorks DW. So I'm asking the server to create a member in this cube, and the name of the member calculated measure is testing. In the same way, I've added extra braces. In the same way, I have to add the cube name for the second one. Instead of this, you have to select the cube name. Now if I go and execute this, it is saying executing the query and execution complete. That means it created these two in my cube. The cube AdventureWorks DW. The difference between with and cube, with and create one is for with it is a query scope and you don't need to specify the cube name, and for the create you need to specify the cube name. Why? Because you have to specify where this calculated measure needs to be created. Now let's refresh this. If you select this, it will refresh. It refreshed and it should be created, right? But it is not created anywhere. These calculated measures are not created. What is this? Then where it is? It will be in buffer. If you execute this, you will get the data. These calculated measures are created, but not in the queue, but in the memory. If you go for the new query window and you execute this, this is not available. Means again come back and execute here, these are available. What is the difference? What is the reason? These are the query window scope. Only until the session scope we call it as. Until this session is there, these calculated measures will be created. For example, if I take it to a new query window, all the queries I have taken to a new query window, and if I close this, then these two calculated measures, whatever we created, will be gone. If I execute this again, it will say these two are not available. Why? Because this is a new session. So again I have to create it and I can execute it again and again until I use the same session. So now let me explain the difference between these three. With keyboard, it is only query level scope. Create, you need to specify the cube name where you want to create, but it is also session level. It is not a complete permanent one. It is a session level, and if you create a calculated measure in your cube, then that will be a permanent one. Whoever has access can make use of the calculated measure. So this is the three different scopes of the calculated measure where you can create it. Now let me go to the new window and see the same. You can see these are not available in this session. This will end whenever I close this session. This is about the calculated measures. We have seen how to add hard-coded values and how to go with some expressions, simple expressions. Again, we have not done complex expressions. And before ending the session, let's see one more thing. This is our calculated measures, right? And the query. If you see, this value is similar to this, right? The only difference is this is not rounded. The formatting is not done. How to format this? After the expression, you can use the format string is equal to just similar to the one that you have given in the here in the cube calculated measure. What you have selected here? You have selected standard option here, and hence it has taken format string is equal to standard. Give the same. If you give the standard and let's see how it will be displayed, how the data will come. If you see here, it is rounded to the standard format. So you can format the data. You can format the output or the measure values using the calculated measure. That is one advantage. Okay. And one more advantage is you can alias. You can alias the measures. Up to now you have seen something, right? Now I'm taking one more number. I'm giving a beautiful name, sales. Total sales. I'll give total sales as I'm not having any functionality except blindly giving this, simply giving this sales amount measure. So whatever the value that I'm getting for the sales amount, just blindly tag attached to this particular new member, whatever I've defined here. So now if I replace this new member with the old member with the new one, and if you execute the same, you can see it won't retrieve the sales amount as the column name. Instead of that, it will retrieve the total sales. So if you want to alias, if there is some awkward or odd names or for any measure, then you can use it as alias part, these calculations. So the calculations are used to, main purpose is to write some complex calculations. Next thing is to format the things, and the third thing is to alias the measure column, measure names. And it has three scopes. One is permanent, that is cube level, and the other one is with query, that is query level, and third one is create, using create, that is session level. So this is about the calculation in MDX. Pretty small concept we discussed. I mean, very little we discussed up to now in calculations, and we have to discuss a lot. I mean, like complex calculations. So we're going to discuss about complex calculations and time functions in next session. So until that, I mean, I want to give a break for you guys to go through all the functions and the concepts we have discussed so far, so that it will not slip from your mind. You need to practice on the same day to stick it in your mind. So I'm ending the session here, and I'll catch you in next session with complex calculations, which is very key. If you write a complex calculation here, you can copy the same in the cube. And one more thing before ending the session, why, when I have this option, why I need an option like creating a calculated number in MDX? The reason is you may need some couple of simple calculations in reports. This is the base one. This is the base cube, and it will have some hundreds of calculations. And if you need some extra calculation, then you can make use of the calculation option, with member option in MDX. Keep that one in mind. If anyone asks you why you need this with member when you have the option of creating the calculated measures in cube solution, then you can say that sometimes ad hoc some calculations in reports. While working on reports, you may need to create some calculations which are not defined in cube. And instead of going and defining in the cube, it's better to define in the, or if you want to override the name, alias the measure name, you can go for it here, and you can say, you can answer like this. So catch you tomorrow in next session with complex calculations and time functions, which is very, very, very important. Thank you very much.